Welcome to lesson 101. We're in the triple digits. Let's go ahead and talk about translating expressions into equations. Up on the board I have a number of different kinds of terms, some monomials, binomials, that kind of stuff. But what we really want to understand here is if you see the word or the term 2n, what does your brain tell you to do? And of course, you're probably thinking, well, I'm going to multiply by 2, or this is twice a number. So you can take a word phrase like twice a number and translate it into this. Just like our second one here, we would say 5 more than a number. Or here we would say 3 less than a number. And so there are different ways to express this. Or if we get here, we could say 7 times a number. And so looking at expressions that are written using words, we can then translate into different kinds of terms based upon what the relationship is. And that's what we're working with in this lesson. So, example 1. If 5 less than twice a number is 17, what is the number? So we want to take this sentence, we want to translate it into an expression. Sorry, into an equation. This is an expression. Let's change it into an equation. It says 5 less than twice a number is 17. Well, is means equals, so I'm going to write that there. And it says is 17. So I'm going to take the easy part and get that done first. Right? From here, I need to do this. Right? The 5 goes with less than, so it's 5 less, or minus 5. And then twice a number. So n is what we don't know, and we're going to do twice to those n's. So 2n minus 5 equals 17. And so we have this idea. Now, to double check our work, we can go ahead and solve this equation and make sure everything's working out the way it's supposed to. And so to do that, I would balance this out. I would say, okay, plus 5 on this side, plus 5 on this side. So now my new problem is twice the number equals 22. And then I divide by 2, balancing it out, and find out that n equals 11. And of course 11 fits our problem, right? 5 less than twice the number. So 22, right? 2 times 11 is 22, minus 5 is 17. And so our expression works, right? This is one way that we can translate expressions into equations. However, sometimes we like to make things a little bigger. Right? Usually we call them word problems. Right? A taxi company charges $1.50 plus $3 per mile metered at tenths of a mile. Right? That's a lot to take in initially, but as we continue reading, we're going to write an equation that relates the total fare of F in dollars to the number of miles in M of a taxi ride. Then we're going to use the equation to find the fare for a 6.4 mile taxi ride. All right, let's go ahead and break this down and start to solve for this. Right? Because we're trying to, if I were to go on a, what am I trying to say? If I were to go on a taxi ride, I would want to know how much I'm going to pay at the end. And of course, that stands for F, fare. So we're going to start with this side, fare equals, and now we're going to figure things out. Now if we go back up to the top sentence, we see that the charges being made have everything to do with the miles, or M in this case. And so we're going to use that to help us to solve this problem. All right. Taxi company charges $1.50 plus $3 per mile metered at tenths of a mile. Okay, well that sounds interesting. Let's go ahead and figure this out. To solve this, we need to understand that we're taking this 150 and we're adding it. That's what plus means. Plus 1.5. In this case, I'm going to leave it 1.5. It's going to make it a little bit simpler expression than writing it with the full money. Not that this would be wrong, but to continue solving this, to get rid of some of these different things, it just makes it a little simpler to understand, right? The other thing we see here is we see this $3 per mile, right? Metered at tenths of a mile. Right? And so it's going to measure it, right, to this degree, just like we see in the problem here. But regardless of that, we know that we're going to take 3 and multiply it times our miles, that $3, and multiply it. So in the end, we come away with this equation. Right? The fare equals 3 times the miles, $3 times the miles, plus the 150 it takes just to get into the cab itself. Now that we've determined the equation, we can then find the fare for this distance, right? And we're going 6.4, and that's where that tenths of a mile comes in, because we're going to have to pay that 4/10 of a mile. We can't just say, oh, round up to 7. I mean, no one really wants that except for maybe the taxi company, because they're willing to charge you more for giving you a shorter ride. But as a customer, we want what's fair. So as we plug in 6.4 for M, we now have this problem to solve. 6.4 times 3 is going to give us an answer of 19.2. And then we're going to add that to the 1.5 to give us add those two together, we get 20.7, and that's going to equal our fare. And because we're dealing with money, this is where we're going to add our symbols back in, because it makes a whole lot more sense to pay $20.70 rather than 20.7, because that's not really how we look at money. All right, so we have another example looking at this, breaking down a problem to solve. Let's see what's next. Oh, it's a sample problem. That means you guys get this one to do on your own, and then we'll check your work to see if you understand how to write an equation based off of this expression. Oh, sounds like so much fun. I'm going to let you get to it. That's the end of lesson 101. We'll talk about this problem in class.